Alright, let's look at another really brilliant concept. It's order and magnitude. So, as you play with this, you know that O is or 3, 4. So basically, number means a specific point on this number line. And then if you look at that, oh, this is a 5. Like 5 is like more to the right side than say 4. Okay? And what about say 2 and then 1? 1's like a more left. 0 is like the at the edges, like a leftist. And what about 10? That's like, oh, go all the way to the right. So you can see that all this number 0, 1, 2, 3, 4, all the way to 10 have a certain order. And then, if you look at that, 10, right, to the right, and then what about 4, left? And if you look at this, you can see that the more right the number is on this line, the bigger the number. The more left of the line, the smaller the number. Of course, we can flip the axis, flip this line, so more left become like bigger, more right become smaller. But let's stick with this convention, left is smaller, right is bigger. If you think about this, we got 4, and also we got 5. Let's compare these two. So 4 is at the left side, and 5 is at the right side. So we can say 4 is here, 5 is here. So 4 is less than 5. And we can also say 5 is greater than 4. Because if the number, right now, I'm sticking with this, the more to the left is smaller, more to the right, small, more to the right is big. So we can use the symbol to represent which number is at which direction. And when you compare these two numbers, it's relatively. Because if, say, 8 and, say, 6, well, 6 is pretty to the right, and 8 is also pretty to the right. So if you compare this, you can say, well, 6 is less than 8, or 8 is greater than 6, because the relative position, the 8 is still bigger than 6. 6 is kind of like a left. The 8 is kind of like a right. So the order and magnitude, you can use this model to understand.